Hello everyone, in this experiment I designed a 2D resistive touchscreen by observing equipotential lines and voltage changes. The setup consists of two identical conductive sheets, a 10-volt DC power supply, and a multimeter. First, on one of the sheets I measured voltage differences on equal distances. Then, for the 2D touchscreen, I alternated the voltage across the X and Y axis to find the exact point of contact. For part 1, I performed a 1D calibration to find the voltage to distance transfer function. Here you can see me measuring the voltage on equal gaps. I applied 10 volts across a single sheet and measured the voltage at 2 cm intervals up to 10 centimeters. Ideally, a uniform 1 volt per centimeter was expected. However, there was an extreme voltage drop throughout the sheet because the conductive sheet had a massive resistance of roughly 65 kilo ohms and nearly 75% of our source voltage was lost as heat. To build the 2D mapping system, I placed a second identical sheet on top. As you can see, to prevent short circuits when unpressed, I separated the layers using several small insulating paper pieces. When physical pressure connects the two sheets, the unpowered top sheet lets the voltage flow through, which gives the electric potential of that specific point. In part 2, I tested the accuracy of our touchscreen across 10 different coordinates. First, I powered the bottom sheet and read the x-axis voltage. Then I disconnected the power, applied it to the top sheet, and read the y-axis voltage. Using our transfer function from part 1, I converted these voltages back into physical x and y coordinates for all of the 10 different coordinates. Ultimately, while the mechanics of a resistive touchscreen were successfully demonstrated, our calculated coordinates didn't match with the actual touch points. This absolute error was mainly caused by the high resistance of our sheet. To improve the accuracy, materials with lower resistance should have been used. That's all. Thank you for watching.